And section 8.1 is going to be about graphing f of x is equal to ax squared. So what happens when you have a square in your graph? So that is known as a quadratic function, and a quadratic function is a nonlinear function that is written as y is equal to ax squared plus bx plus c. And today we're just going to focus on this y equals ax squared bit. And the resulting graph is called a parabola. So that's all the information we need to get started today. And I just want to go ahead and start by actually graphing one of these guys. So here we are given a graph, and there's two sides to a parabola. So a parabola is going to be a U-shaped sized structure, and it's going to look like that. And this is a parabola. In fact, this is going to be the graph f of x equals x squared. Notice that on our right hand side right here, we are increasing. Oops, how did that make a triangle? All sorts of crazy stuff just happened. All right, so on this right hand side right here, we are increasing as x gets bigger, and as x gets bigger on this left hand side, we are decreasing. But both are going up towards infinity. We have a point down here where these two red and blue sides meet. This is known as our vertex. And our vertex is at the origin, 0, 0. And notice that the graph here is symmetrical down the y-axis. So everything on this red side matches everything on this blue side. And so this yellow dashed line, that is going to be called our axis of symmetry. So it's mirrored. All right. Here's some nice information to know. The vertex, once again, is 0, 0. The axis of symmetry is the y-axis. The domain of this function, or the x values, what x can be, is all real numbers. In fact, it will be all real numbers for all parabolas. And then the range is going to be y is greater than or equal to 0. So whatever this y value is in your vertex, that is also going to be what your range is. It will either be y is greater than or equal to 0 or y is less than or equal to 0, depending on which way the parabola opens. So on this first example that I want to do, I just want to identify all those different things that we just talked about. So we're going to be given a parabola once again. So here's our graph. We're going to have a point down here at 2, -3. And we are given the following parabola. So we go up into the right. Oops, let me redraw that. And we're going to go up into the left. All right, and we want to identify the following pieces of information. So let's go ahead and try to identify the vertex, the axis of symmetry, the domain, and finally the range. So the vertex is already given to us. It's down there 2, -3. The axis of symmetry always runs through the vertex, and in fact, it's always going to be our x-coordinate in the vertex. So that's going to be x is equal to 2, and we can, oops, I made a mistake. I'll just add another tick mark in there to make that 2. But x is equal to 2 right here, so we can draw a dashed line all the way up. So there is our axis of symmetry. Just stated that the domain is all real numbers, and the range is going to be our y value in the vertex, so that's going to be y, and notice that y is getting bigger. We're getting bigger, so we're going to say y is greater than or equal to -3. If our parabola was opening down, we would say y is less than or equal to -3. So now how do we actually graph a parabola? So let's look at graphing f of x is equal to ax squared. And we're going to be given two possibilities. When a is greater than 0, a can't equal 0 because we won't have a parabola, or when a is less than 0. So we're going to give a couple of graphs here. These are going to be generic. All right, so we're going to do all of our a greater than zeros in blue and green style colors. And if a is equal to 1, then that's the standard graph, f of x equals x squared. So this is when a is equal to 1. This darker seaweed green is going to be what happens when a is greater than 1. So as a gets bigger, the graph gets narrower. And then as a gets smaller, closer to 0, becomes a fraction, we're going to get this really wide bowl kind of thing. And that's going to be 0 is less than a is less than 1. And then we're going to do all of our downward opening ones in orange. So if a is less than 0, we're going to have a negative a. So it's going to turn all those numbers negative. So the standard a is equal to a -1 is going to be right here. And then if we get a smaller negative number, so like a is greater or less than a -1, like a -7, we're going to be in this territory right here. So a is less than -1. And then if a is between -1 and 0, we're going to get that wide bowl-like shape again. So that is a, oops, sorry. -1 is less than a is less than 0. So just know they can open up wide, they can open up skinny, they can open up towards the top, and they can open up towards the bottom. So now, why don't we just go ahead and actually graph a couple of these? So we're going to first graph g of x is equal to 2x squared. So we're going to go ahead and get ourselves a graph right over here. So there's our graph. And let's go ahead and just start plugging in some numbers into a table. So we're going to have x on top, g of x on the bottom, and then we'll just plug in numbers to see what we get. Let's start in the middle at a 0, because 0 is a nice number to start with. The vertex of all of these singular term monomials are always going to be 0, 0. So if we plug in g of 0 into this function, we're going to get 2 times 0 squared, which is just equal to 0. And then we're going to go 1 and 2 on the left-hand side, and -1 and -2 on the right-hand side, or vice versa. So let's plug in g of 1. That is going to be equal to 2 times a 1 squared, which is equal to 2 times a 1, which is just equal to 2. And then we're going to do g of 2 is equal to 2 times 2 squared, which is equal to 2 times 4, which is equal to 8. So notice that these get really big really quickly. Then let's plug in g of -1 in. That's going to be 2 times a -1 squared, which is going to be equal to 2 times 1, which is equal to 2. So notice that these two are identical, because that is our axis of symmetry there. And then finally, we're going to have g of a -2 is equal to 2 times a -2 squared, which is equal to 2 times a 4, which is equal to 8. Notice that these two are also similar. So really, you only have to find one half of your table, because the other half is going to be mirrored. So now we can plug those in. We're going to plug in 0, 0. We're going to plug in 1, 2. And then we're going to plug in 2, 3, 4, 5, 6, 7, 8 up there. So here is our right side of our graph. And then the left side is just going to be mirrored of that. So we take those same points, mirror them over here, and go on up. And that is the graph of g of x is equal to 2x squared. Next, why don't we look at something a little different. So this is going to be the graph of h of x is equal to -1/3 x squared. So once again, we need to have a graph. All right, so pretty large graph here. And why don't we make a table again? So we're going to make h of x and x. And we're going to start at 0 again and be centered around the origin. So let's start at 0 here. And then notice that we're working with a -1/3 here. That's just not a very nice number. So why don't we take numbers that are easily divisible by 3? So let's do a +3 and a +6. And we'll do a -3 and a -6. We could have done 1 and 2 again, but that wouldn't have been very helpful for us. So now let's plug in some different numbers for that. If we plug in h of 0, we're going to get -1/3 times 0 squared, which is just equal to 0. So we're at the origin again. And then I'm just going to do the right-hand side, because from our first example, we see that the right and the left side are mirrored. I'm not a big fan of negative numbers, so we're just going to go and focus on that right-hand side and then copy the leftovers. So let's do h of 3 is equal to a -1/3 times by a 3 squared. 3 squared is 9, so that's going to be a -1/3 times a 9, or a -3. Next, let's do h of 6 is equal to a -1/3, 6 squared. So that's going to be a -1/3 times by a 36, and 1/3 of 36 is equal to a -12. Once again, these grow rather quickly. Then we're just going to mirror over there, so that's going to be a -3, and that's going to be a -12. So we're going to go out to a 3, -3, and a 6, -12, so all the way down there, and then we're going to mirror that on the other side. Like so. And then just complete our parabola. The hardest part about the parabolas is in fact drawing them correctly. And if you